Hi, everybody. Let's do IXL pre-calculus find a unit vector. So the first question here is find the unit vector u with the same direction as t, where t is -4, 9. Those are the components of t. Okay, so the first thing that we're going to want to do here is find the magnitude of vector t. So we need to do the square root of -4 squared plus 9 squared, which would be the square root of 16 plus 81, which is the square root of 97. Okay. So in order for us to find a unit vector that's in the same direction as t, but has a magnitude of 1, we would simply take the components of t and multiply them by 1 over the square root of 97. So the components of u would just be -4 over the square root of 97. And that's the horizontal component. The vertical component would just be 9 over the square root of 97. Okay, because when we do -4 times 1 over the square root of 97, just simplify that with that's -4 over the square root of 97. Okay, and similar if we're multiplying this by 9. All right, we can verify that this does in fact have a magnitude of 1 if we do the square root of -4 over the square root of 97 squared plus 9 over the square root of 97 squared. Then this would be 16 over 97. All right, and plus this would be 81 over 97, because if we do the square root of 97 squared, then that would just give us 97. Okay, and this is equal to the square root of 1 over 97 times 16 plus 81. All right, and then we could write this as the square root of 1 over 97 times the square root of 16 plus 81, which is 97. So, and actually we can rewrite this as the square root of 1 over the square root of 97, but the square root of 1 is just 1. So what we have in the end here is that the magnitude of this vector, which we wrote, is 1 over the square root of 97 times the square root of 97. So these would cancel and we would just get 1. I actually feel a little bit silly because there was an easier way to simplify this. 16 97ths plus 81 97ths is equal to 97 97ths. 97 97ths is just 1, so we have the square root of 1 here, and the square root of 1 is 1. Okay, so that's probably an easier way to simplify that. So we just verified that the magnitude of this vector is in fact 1, so it is a unit vector. Remember, a unit vector just means that the magnitude of 1. And it would also be moving in the same direction as t, because if we just take the components of some vector, in this case t, and we multiply each component by the same number like we did here, then the resulting vector would be moving in the same direction. That's no matter what number we multiply these components by. We multiplied them specifically by 1 over the square root of 97, so that they're not only moving in the same direction, but also the magnitude of the new vector is 1. But any number times these components would give us another vector moving in the same direction, at the very least. All right, so let's move on to the next problem. Oh, I was so afraid that I would forgot to simplify. Is there a way to simplify the square root of 97? No, I got it. Now I know how you guys feel when you put all that work in. And then it says no and your smart score goes down, right? But it didn't happen to me that time, so I'm happy. Okay, find the unit vector u with the same direction as 1, 9. Again, if this is our vector t, then the magnitude of t would be the square root of 1 squared plus 9 squared, which is 1 plus 81. Okay, so we're going to get the square root of 82. So this would just be 1 over the square root of 82, the horizontal component, and 9 over the square root of 82 for the vertical component. Let me think. I don't think there's any way to simplify the square root of 82, right? So what I would be looking for in order to simplify this is this number divisible by any perfect square? Then I might be able to simplify it. Let's see. 4 is a perfect square, 9 is a perfect square, that's 3. 16 is a perfect square, 25, 36, 49, okay, 81, whoops, I skipped 8 squared, 64, 81, 100. I don't think this number is divisible by any of these, so I cannot break this down into 2 factors where one of the factors is a perfect square. So I'm not going to be able to simplify this. So it's just going to be that. All right, find the vector with, okay, so I think we get the idea here. Let's move on to the next level. Find the unit vector u with the same direction as w, where w is equal to I minus 4j. Okay, so that just means that the components of w are 1 because there's no coefficient in front of this I here. So if you don't see a coefficient, then it's 1. And the vertical component would be negative 4. So again, we're just going to find the magnitude of w, and that would be the square root of 1 squared plus negative 4 squared, which is 1 plus 16, which is square root of 17. And there's no way to factor this where one of the factors is a perfect square. So we're just going to write our final answer now. So the components would be 1 over the square root of 17 and negative 4 over the square root of 17. Okay. Okay, I already skipped the level. Let's see over here. So w is equal to 0, 2. The magnitude of w would be 0 squared plus 2 squared, which is 0 plus 4. 0 plus 4 is 4. The square root of 4 is 2. Okay, so that one was pretty easy to simplify. All right, so then this would just be 0 over 2, which is 0, and 2 over 2, which is 1. Okay, so for that one, you would have to be careful. All right, let's do this one, and I think then we'll call it a day. The magnitude of vector t would be the square root of negative 5 squared plus 5 squared. Negative 5 squared is 25. 5 squared is 25. Okay, this is 50. So I have the square root of 50 now. Can I break this down into so that I have 2 numbers here where one of these numbers is a perfect square? In other words, is this number divisible by those numbers that I had before? 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. I'll just do it up to 10. Why do I keep writing 80? 8 squared is 64. 9 squared, 10 squared. Okay, yes, this number is divisible by 25, right? It's 25 times 2. And so the square root of 25 is 5, and then we still have the square root of 2 there. So we can simplify this and write it as 5 times the square root of 2. Now over here, we could put in negative 5 over 5 times the square root of 2. And over here we could do 5 over, I'm just taking these numbers and putting them in the numerator, okay? So 5 over 5 times the square root of 2. But we can simplify further because we have a 5 here and we have a 5 here. Those would cancel out, and we would just get 1 over the square root of 2. So let's actually erase these 5's. Right, 1 over the square root of 2. And here we would just have negative 1 over the square root of 2. So the 5 still canceled, but one of them was negative. So we have a negative 1 instead of positive 1 now in the numerator. Or you could put it in the denominator. It's the same. Okay, so there's our answer there. All right, and I think you get the idea. There are no other levels for me to do here. So they're all pretty much the same. So I'm going to end the video there, and have a great day.